This is H2S. I tested it with many materials and it has one fantastic property. Try to guess which one. Hello, welcome to my tech farm. This is H2S 3D printer by BambuLab, and this is the first printer which I got from them before the official premiere. I got this box for free, but there is no additional payment. However, this video and the whole channel is sponsored by Polymaker. If you are following my channel, then probably you know that X1 Carbon is my main printer for printing those test objects where I'm doing filament reviews. And there are only three reasons when I'm moving to the KD Plus 4. One of them is when I need a print temperature above 300 degrees Celsius, or actively heated chamber, or if I need a bigger working area. And all three I will get with this printer. And if this new printer will work similarly like X1 Carbon, then I'm moving to this one for printing all my test objects in the future filament review videos. But what is the main difference between H2S and H2D? I got H2D for the review, it is in progress, but more logical timeline for me is to do the review video of this one and then to see advantages of the H2D. But even H2S has some advantages compared to the H2D. First of all, bigger working area, because here we have only one nozzle which can reach all points on those working areas. With H2D we have two nozzles and one of them cannot reach one side or the other side of the working area, and this is cheaper. Others, no nozzle camera on H2S, different side panels, nozzle wiper, and no 40 watt laser compatibility with H2S. Just quickly let's see other specifications. Working area 340 by 320 millimeters along the X and Y direction and 340 along the Z axis. This is the combo with AMS2 Pro. It has servo motor extruder, it is full of sensors, 3 onboard cameras, actively heated chamber up to 65 degrees Celsius, and it has a possibility for low temperature printing with the closed doors for PLA PETG. If you're not familiar, usually for these materials you have to open the doors, and in this case the printer is much louder, but if we have some possibility of internal cooling or something like that, in that case we can do this with the closed doors and it will be much quieter. Maximum nozzle temperature 350 degrees Celsius, on the bed 120. Another small advantage, because in Europe on X1 Carbon the maximal bed temperature is 110 degrees Celsius. It looks like here it is 120, but I will check this later. The speeds up to 1000 millimeters per second. This is the toolhead speed. Of course the printing will be probably lower or slower, and 20,000 millimeters per square second is the acceleration. It is important to mention that I got the request quite late, and first they sent me the US version and then I had to wait for the replacement for EU version, and basically now I have a little bit more than 1 week for the testing and video editing. But this is BambuLab, so I couldn't reject this request, and I will do my best. I mean, I will test it with many materials, and I think this is enough to put, I don't know, a few hundred hours in it. But if you still think that this is not enough, don't worry, you will see this in many filament review videos, including BambuLab PPS-CF. Now let's unbox it. The doors I can open in a 180-degree angle, and the AMS unit is inside. I think it's holded with these bolts. And also it is very important to remove these bed locking screws. They are marked with these red arrows. It arrives with this two-sided texture PI sheet, which is great for many material, especially for the PLA. Now, for those engineering technical filaments, I really had a great success with my engineering plate, which is unfortunately discontinued, and the replacement is the smooth PI sheet, which I have to order as soon as possible. Another small advantage compared to the X1 Carbon, it uses linear rails now. I'm an old-fashioned mechanical engineer, and actually I don't know anything about carbon rods, so I think in my eyes this is a better solution. Now let's talk about AMS2 Pro, which can even dry the filament and rotate during the drying. The maximal temperature is 65 degrees Celsius, and now we can see these Teflon lines, which is very good because if you have some broken filament inside, it is much easier to take it out, unlike with the old AMS, which is quite closed, and there I needed, 15 minutes to do this operation. This inlet is now ceramic, it will not wear out, for example, because of those carbon fiber filaments, but most of them cannot go into the AMS unit. There are some exceptions, and there this is very useful. Now, unfortunately, it cannot dry during the printing. I think this is big disadvantage of this. And for the old AMS, we have some units from Sunlu, iBoss, which can be added and we can dry during the printing too. I'm curious when will those things appear on the AMS2 Pro. The screen angle is adjustable. There we have the USB port. And a warning, please do not place any object on the automatic top ventilation here. So big space for the storage. And maybe for the HT-AMS. Connecting the AMS, this is the Teflon tube and the cable connection with the printer. And pay attention to this. Spool holder from a side. A message to other companies: start copying this solution and stop placing the spool holder on the back side of the printer. Safety key, and it goes here. Maybe this is the location for the emergency stop button for the laser version. From the toolbox we have some lubricant, spare parts, camera cover, but only one thing I want to mention here, that this is the hot end. 0.4mm nozzle. Let's turn it on, and I'm very curious what kind of illumination it will have, because it is quite dark inside. Nice and bright. I like this. And as you can see, no smoke. This means I unboxed the correct version, because the US is down in my basement. The easiest way to add the printer to the handy app is to scan this QR code. And MyTechFun is logged in. Before the calibration, they told me to update the firmware. Firmware is updated. Now I can finish the calibration. Calibration finished. I can insert the filament and it's ready for printing. First material, PLA Basic, magenta. It's noticeably faster than the AMS sold unit. Let's see what's prepared. Speedboat race, okay. And all printings, including PLA, will be behind the closed doors. Hello, it's Igor from the future. Before the main part of the video, I want to mention something because it will explain few things. My printer arrived with the issue. These top ventilation doors are stuck and cannot be opened. And I noticed this only when all my PLA and PETG test objects are finished. After that I tried to open it manually with my hand to see if it's stuck, and now it is stuck in open position. We are working on a solution with the BambuLab, but I don't have time to fix it for this video. Otherwise, everything else is fantastic. Now back to the video. It started and it is noticeably quieter compared to the X1 Carbon. Of course, closed door helps a lot here. And I really like these lights. They are from two sides. I'm still missing one from the front side too. Printing is at 38%. All fans are working now. (45–46 decibels from half-meter distance. That's incredibly quiet. Thank you, BambuLab, for this. The printing is at 60%, and I'm talking in the meantime. This is not a voiceover. It is incredibly quiet. These rubber legs are really flexible, but at least the desk don't take over these vibrations. Last few layers, and I know that the bed adhesion is great with this textured PI sheet, but not on 55. Usually I print on 65 degrees Celsius. I will just do a quick check when it's finished, which is actually now. It's really good. This LED strip is also very interesting. I think BQ starts selling something similar for the older printers. Okay. At the first look, not bad, really nice quality, except here. I'm not sure is it visible on camera. And this big overhang means that they don't have enough part cooling here. So maybe for the PLA it's still better to print with open doors. Sad conclusions. Actually, wait, this is the speed Benchy printed very fast. What if I slice my own Benchy and use different settings? Let's try that. H2S added 0.4mm nozzle and 0.2 standard profile. Printing time will be 31 minutes. Here you can see how it looks like. Very nice and bright camera. So this is the Benchy sliced by me using standard 0.2mm layer height settings. And as you can see, the doors are closed again. I think this top vent should be open for the ventilation to reduce the temperature when we are printing PLA, but I'm not sure when, so I don't think I will catch that moment. I wasn't even here, I was supervising over the network. So this is the speed Benchy and this is with the standard settings, and it is okay, but it is really on the edge of the acceptable. Reprinting the same G code, but this time the doors will be opened. And this time the noise went up to 55 decibels approximately. I know I could rotate the Benchy so the front side will face this aux fan, but sometimes we don't have the option. Let's say we have some object printing where we have those critical overhangs on 2 or 4 sides. It's finished and now let's compare the quality. So this is a speed Benchy, closed door, open door. Extremely similar, just slightly better quality on this one, but I think it is hardly noticeable. I don't know how could I forget this, it needs a poop chute. This will be one of my next printings. But first bed leveling test, which became a standard experiment with reviews. Start of the bed leveling test is good, behind closed doors, which is not so good for the camera because of this mirroring, but definitely good for my environment because it is much quieter. It's finished, I will analyze it later. Interesting, all 4 fingerprints are visible. This is my typical movement when I am flexing it to remove some object. This is absolutely acceptable. It is almost perfect, except on this area here I can see some imperfections, but definitely the second layer will completely cover this. This small imperfection is here, I'm not sure if you can see it on the screen, but even there those layer lines are completely connected and this is definitely like a paper. Later I will do this test with the ABS2. Cleaning with isopropyl alcohol. One thing I noticed on the screen, I didn't pay attention to this. White PLA is approximately at 50%, and even here I can see that, and that's correct actually. As you can see, this is approximately at 50% on the spool. Do they follow the usage of the filament in the center? Because this is first time it is in this printer. Before multicolor printing I need a poop chute, because there will be a lot of waste materials. And I'm printing this from the PETG. I don't like this to print from the PLA because some hot material may stick to it. I'm using completely different settings for this material. And this will be almost 4 hours of printing behind closed doors. The printing is at 32% and there is some minimal stringing because I don't have time for drying the filament. I wasn't even here, the bed completely cooled down. But it still sticks good. Okay. There is something I noticed later. This side is smooth and it's completely usable. But check the back side. So here it started that big overhang and it had some problem, and here I had to left home, so just in case I opened the door, and actually it was better. So the part cooling is not enough, but later I figure out what is the problem, but I will talk about it later. Really nice design because it minimally blocks these ventilation holes, and now the bucket, it can be even from the PLA. Recently I noticed this error. Automatic top vent air door, malfunction, it may be stuck. And actually I never saw these doors to open, so later I will check it, but when the printing is finished. Until that I am printing with open doors. Printing at 41%, 2.5 hours more, but it will be finished overnight. Good morning. It's already removed. Now it is ready for the multicolor printing. Just another printing prepared by manufacturer in 2 colors, and I opened these top vent doors manually. It will be finished soon, and the color changes are along the whole layer, so the amount of the waste material is not huge. Now I want to do the bed level test with the ABS-GF. Theoretically it can go into the AMS unit, but it's quite brittle. I hope everything will be fine. And this time I'm cleaning the bed with isopropyl alcohol. The start is really good, and this time there will be no fingerprints. The bed temperature is 90 degrees Celsius and it's almost finished. Looking very good. Actually, this is the best auto leveling test which I did with the ABS filament. This is some dirt from the nozzle, and again here are some small imperfection like with the PLA. But this is like a paper. All lines are corrected. Here is another experiment, Salo ASA, and I'm curious about the layer adhesion if I print it on X1 carbon compared to the H2S, which has actively heated chamber. Since I cannot close the ventilation doors anymore, this is my sealing method because the actively heated chamber will be 60 degrees Celsius inside. I forgot to record, but it heats up the chamber very quickly. After third layer it was already 60 degrees Celsius inside. Printing will be finished in 3 minutes. And these are printed on X1 carbon using the same settings, except here I don't have the chamber heating. These are not my standard test objects, they are hollow inside. And now printed on H2S. 50% stronger. Now seeing this, I have a very important question for you. And in the same time when I will publish this video, I will start a poll on my YouTube channel. And the question is if I will use the H2S for my future ABS or similar technical filament testing. Should I use the actively heated chamber? Because as you can see it is quite different compared to the X1 carbon, which has only passively heated chamber by heated bed and the nozzle. With H2 printers and active heating we will get the best possible results, but still X1 carbon P1S and similar printers are much more popular, so I can test something which is more spread between the users. I'm not testing both. Maybe at the beginning the layer adhesion I can do 2 printers, but in the future videos definitely I have to choose only one. PPS-CF, I have the review in the progress. Let's measure how brittle is it. It will be important later. Start angle 30 degrees. Around 70. It's close to the brittle category, but still acceptable. Since it cannot go into the AMS, I'm using the external spool holder. I'm using the glue stick. And doors will be closed. And it started, but not easy to watch because black filament inside the enclosure. Let's check the camera from the printer. And through this camera, it is much cleaner and easier to follow. It just started with the 4th layer and the temperature is stable 65 degrees Celsius inside. In 4 minutes printing will be finished. A review video of this filament will be finished in approximately 10 days. And as always with the PPS reviews, a bell. And now printing with PPA, and even the printing will be from the filament dryer. Okay, so let's see how brittle is the PPA-CF filament. Start angle 30 degrees. 68, so below 40 degrees. I don't like this bending. It reminds me to the K1 Max. I had a lot of problems there. This could be even bed level test, which is great. Only thing I'm worried about is this bending in this corner. It's quite big. This is what I was afraid of, and this is the second time it happens. On X1 carbon it never happened so far. Not sure if you can see it, it's broken here. Oh, it's broken again. And now I notice direction is broken too. Okay, it was not broken, just jump out from its location. Now I'll try to print this graphic, but I will move it maximally to the front. In this case I will have less bending here, if it survives the auto leveling. Yes, finally it started, so it survived the auto leveling. And if it will fail one more time, then I am done with this filament on this printer. And this is the maximal bending now. It should be okay. One more hour of printing, but it will be finished overnight. Good morning, and look at this beauty. So with brittle filaments, avoid this area if they will survive the auto leveling. It will hold 1 meter alu extrusion, and you will see it soon in my falling ball impact tester. Still PPA-CF. In the morning it was broken inside Teflon tube in 3 pieces, and I had one failed auto leveling. But now it's started and it should be okay because I'm not using the right back side of the print area. And these are real functional parts for my new wearing test machine. And this will be long printing, 5 hours. And look at this. Printing is finished in 5 hours and 7 minutes. It's still hot. Let's check the PPS-CF which I use for the bed leveling. Start angle 25. Around 110. And this was easy for printing in this case. From BambuLab I got this suggestion. Remove the tube from the drag chain, rotate it 360 degrees and insert back into the tool head. This will reduce the bending, but I think now it will drag against the top glass. Probably the riser would be the solution here. I know everybody is waiting for that color PLA printing with a lot of waste material, but this is more important for me. PET-CF. This is some kind of budget-friendly option for technical filaments. And recently I did a comparison of 5 PET-CF filaments. And I got even the messages that I have so many useless testings. One of them is this filament bending. But let me show you something. This is Siraya Tech. Break around 40 degrees approximately. And this is Fiberon from Polymaker. Around 60 degrees difference. So with this filament I'm expecting almost similar problems like with the PPA-CF you recently saw, and probably with this I will not have any problems. And as expected, this printing is also smooth without any problems. And printing will be finished soon, but even here it enables the chamber heating. And soon there will be a comparison video. I want to compare them with the same size aluminum parts. And now back to PLA and AMS. Top ventilation opened. And now color PLA printing. And we have these penguins, and every time my youngest daughter have a guess, they ask one for the gift. So I never have enough from these. And very important to remember, if I print 1 or 1 over 9 or 10, I will have the same amount of the waste material. But also the time usage will be much better. I will print 9 at once, and the printing time will be almost 7 hours. And look at this waste material, which will be similar if I would print only 1. The start of the printing is perfect. This is the second layer, and I don't need a glue for the PLA, but I was lazy to clean it. And the printing is behind the closed doors, but with open top vent. This is a time-lapse video to present you the ratio between the layer printing time and color changing time. Until with the old AMS, it changed the color in a little bit below 2 minutes. Here it was done in less than 1.5 minutes. So improvement is noticeable, but of course this is not a tool changer. If you need only 2 colors, then H2D is the champion here, but it will be presented in one of my next videos. And it finished the job in 6 hours and 53 minutes, and just sitting here quietly waiting for my next command. And this time I didn't forget to enable the supports. And again, don't forget that we have a lot of waste materials with this kind of printings. And this is a recorded time-lapse video, not exactly full HD, a little bit shorter on the x-axis, but close enough. I have 2 more days for the video editing, but it will continuously print, only not everything will be included in the video. And this will be another PLA printing, more than 5 hours. I'm not sure what is this Labubu madness between the kids, but I need 4 more from these. The progress is nice and quiet, and it will be finished overnight. Now the conclusions, and actually I have less than 2 days for the video editing for this one and also for the Hungarian version of the video. So I don't have time to fix these ventilation doors yet, but I already got the instructions from the BambuLab what to check. I don't think this is some typical error because H2D has the same ventilation door, and I couldn't see not even one complaint on the internet for this error. Avoided brittle carbon fiber filaments. The BambuLab knows about the problem, and Bambu Studio even give us a warning about this if we want to send out this kind of printings. Their solution is to take out the Teflon tube from the drag chain, twist it and place it back to the tool head, but in this case or we have to remove this glass or maybe to print some kind of riser for it. Otherwise, I really like this machine. Even now I'm talking, it's printing next to me, and this is extremely quiet. Also, I like that the first time I did that bed leveling test successfully with PLA and ABS, independent from the bed temperature, so it just works great. And this may be my main printer for my future filament testings. If you have some other experience with it, write me down in the comments section a few lines. Thank you for watching and happy printing.